Okay, here's a great stoichiometry question. If maybe in high school chemistry, you saw a video where someone threw solid sodium in water and it uh, sets off sparks. It's very reactive with water. But one of the dangers with that is it releases hydrogen gas, as you can see in this reaction. So we have to be careful when you're doing that. So what we're going to do is see how much hydrogen gas is released. And we have to be careful because hydrogen gas is flammable. When we throw 1 kilogram of sodium into water, unlimited amounts of water. So you can see here we're given volume, we're given mass, which looks like it needs to be converted to grams, and we're given temperature. And so we need to start out with a stoichiometry problem like we did last term, and then we're going to use the number of moles to calculate pressure. Okay, so first thing we have to do is convert kilograms to grams. So we have 1 kilogram. There is 1 kilogram per 1,000 grams. So we have 1,000 grams, 3 significant digits on that, of sodium times how many grams per mole? 22.99. 1 mole of sodium. And now here's our stoichiometry key, mole ratio. We have 2 moles sodium for every 1 mole of hydrogen. And we're going to stop there. We're not going to solve for grams. So we have 1,000 divided by 22.99 divided by 2. We get 21.75. I'm going to keep an extra digit for right now. Moles of H2. Now I got to rearrange my ideal gas law to solve for P. So I have PV equals nRT. I'm going to make that P equals nRT over V. Now I'm going to plug them in. 21.75 moles. I'm going to go with ATMs because that's what is being asked in the question. So 0.0821 liter atmospheres, mole Kelvin. Temperature is 50 plus 273, 323, all over 20 liters. Let's get units, moles cancel, liters cancel, Kelvin cancels. So we're left with atmosphere. Okay, so 21.75 times 0.0821 times 323 divided by 20, 28.8. 3 significant figures. There we go. So moles are the key. Stoichiometry. Chemistry is done in moles because it tells us how many molecules are reacting. Then we can use those moles in our ideal gas law.